Example 9, baseball is hit at a point 3 feet above the ground at a velocity of 100 feet per second and an angle of 45 degrees, and there's a function that gives the path of the baseball. Will the baseball clear a 10-foot fence located 300 feet from home plate? Let's use our function and find out. So, in we go. We're going to plug in x is the distance from home plate. So here we go. F of x equals negative 0.0032, and we're going to go 300 feet from home plate plus 300 plus 3. We're going to do some simplifying on this. If we simplify this out, we're going to get 15. Sorry, this is driving me crazy. .300 feet away from home plate, the ball is going to be 15 feet high, so it will clear that fence. Go ahead and try exercise 93. Alright, if you're ready for the answer, let's check it out. The height, y, and feet of a baseball thrown by a child is given by the function y equals, where x is the horizontal distance from where the ball is thrown. Will the ball fly over the head of another child 30 feet away trying to catch the ball? Alright, so let's find out. Y equals negative 1 over 10. 30 squared plus 3. 30 plus 6. Sorry about that. Alright, so let's jump back in. Negative 1 over 10, 30 squared is 900. A tenth of 900, let's cancel out some zeros, and so we'll have negative 90. 3 times 30 is plus 90, plus 6, 90, and negative 90 cancel each other out. We're going to be 6 feet high, and this child who's trying to catch the ball holds a baseball glove at a height of 5 feet, and the ball is going to be at 6 feet, so yes, that will go flying over his head. Poor child. Alright, last example here, example 10. A number v in thousands of alternative fuel vehicles has a piecewise function. So there's one formula from 5 to 9 and another from 10 to 16. Alright, use this function to approximate the number of alternative vehicles for each year from 95 to 2006. What we're going to want to do on a problem like this, well, we could do it a couple of ways. We could plug them all in and get answers, or I would highly recommend using your calculator with your table setting. Now we're going to have to do this twice. We're going to go y1 equals 18.08 x plus 155.3, and we're going to do that. First we'll go to our table, and we want answers from 5 to 9. So if you go to your table set on your top line, we want to start at 5. Your table start is going to be 5, and your delta, your step, would be 1. It'll spit out answers for you. You're going to get 5 through 9, and then if we go back in and change our y1 equals to our second function, and then we're going to change our start value to 10, still stepping by 1, we could get ourselves an answer. Alright, so problem 95 for you to try if you've already tried it. We'll find all the values from 1998 through 2007. And I'm going to not go through this one. This is a calculator problem. Check the answers at the back of the book on problem 95. If you did not get this correct, talk to me about this in class because it's probably a calculator related error. Alright, so remember 95, check the answers in the back of the book. If you agree, fantastic. If not, let's discuss it in class. And here we go. Difference quotients. This is our last example of the basic definitions. F of x plus h minus f of x over h. That is your difference quotient. Alright? So for f of x equals x squared minus 4x plus 7, let's find the difference quotient. So f of x plus h. Let's just figure out what that is first. We're going to figure out the first part. It would be x plus h squared. Remember, everywhere we see x, we're plugging in x plus h. Minus 4 oh my goodness, sorry. The board does not like me. X plus h and plus 7. Let's go ahead and factor this. X squared plus 2xh plus h squared minus 4x minus 4h plus 7. And then we have the f of x, which we already know. We just need to be really careful with distributing the negative. So we have minus x squared plus 4x, because we're minusing a negative, minus 7. That's our numerator. Let's go ahead and simplify this before we do anything else. X squared minus x squared. We've got h squared as our largest term. Negative 4x, 4x, 7, minus 7, h squared plus 2x h minus 4h all over h. And let's go ahead and divide everything we see here by h. You'll notice that every term on the top has an h in it. So we'll end up with h plus 2x minus 4. Alright? And that is our difference quotient. Go ahead and see if you can solve this yourself. Alright, if you think you have an answer on your difference quotient, let's give this a shot. F of 2 plus h first. And let's see what we got here. H squared plus 3h, and 4 minus 2 is 2, plus 1 is 3. So that's our f of 2 plus h minus f of 2. So f of 2 is going to be 2 squared minus 2 plus 1, which is 4 minus 2 plus 1. On this one we've got minus, it's our negative here, and 4 minus 2 plus 1 is 3. So we'll plug that in there. All over h, cancel, cancel. H squared plus 3h over h. Final answer, h plus 3 is our different quotient. All right. Hopefully that made some sense. If not, I will see you in class for questions. Last thing that's in the book, there is a nice summary of all this function notation. This can get a little complicated, so if you need to, go back and look at this. Thank you.